ओम श्री परमात्मने नमः। श्री गुरुभ्यो नमः। श्री महागणपतये नमः। मातापितृभ्यो नमः। सदाशिवसमारम्भां शङ्कराचार्यमध्यमाम् अस्मदाचार्यपर्यन्तां वन्दे गुरुपरम्परां शङ्करं शङ्कराचार्यं केशवं बादरायणं सूत्रभाष्यकृतो वन्दे भगवन्तः पुनः पुनः। सरस्वतीमहं वन्दे वीणापुस्तकधारिणीं हंसवाहनसमायुक्तां विद्यादानकरीं मम निधये सर्वविद्यानां विषये भवरोगिणां गुरवे सर्वलोकानां दक्षिणामूर्तये नमः। सप्तर्षयः बौद्धायन कात्यायनापस्तम्भयाज्ञवल्क्यपाणिनि पिङ्गलादिवा पण्डितान् आर्यभट्टवराहमिहिरब्रह्मगुप्तभास्करमहावीरमल्ल मल्लन्न श्रीधर नारायण पंडितः लल्लादि आचार्यान् जगद्गुरुशङ्कराचार्य श्री 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 भारती कृष्णतीर्थस्वामिनः श्रीनिवास रामानुजन् महलनोऽपि शकुन्तलादेव्यादिनवगणितशास्त्रज्ञान् अस्मत्पर्यन्तं सर्वान् गणितविद्वज्जनान् अभिवादयामि।
Namaste, myself Nivan Sharma, speaking about ganithashastra, the indigenous mathematics and its versatility.
The word ganithashastra is derived from two Sanskrit words, gana and shas. Gana to count, shas means to teach or instruct. The instructions of counting gives a similar meaning to the word mathematics, but ganithashastra's scope is much broader to the modern mathematics, which includes Bijaganita, Vyaktaganita, Rekaganita, and Goladhyaya. Ganita Shastra is not taught as a whole from the Vedas, but the Vedangas, Upavedas, and Shastras, which help in performing Vaidika karmas, have Ganita Shastra as a part of it. The references of geometrical structures, number series in the Vedas, and related scriptures indicate clearly that the scholars had the Ganita Vijnana. Vedas, which are Apaurusheya, are eternal and their manifestation age is not known. So is the age of Indian mathematics. It is eternal. Among the Vedas, the Kalpa, which consists of the Shulabha Sutras, and the Vedanga Jyotisha, which consists of astronomical concepts including movements of planets, speed and distances, and measurements of them, and Shilpa Shastra, which consists of the measurements and design of temples and the statues in it, has Ganita involved in it. The Ganita Vidvans of India started decoding the Ganita present in these Shastras and framed into rules, theorems, and postulates. These concepts are divided into arithmetic Vyaktaganita, algebra Avyaktaganita or Bijaganita, and Kuttaka solving indeterminate equations, Goladhyaya, Shulava Sutras, Rekha Ganita, which are related to geometry. The verses of Vedas from Taittiriya Samhita of Chamaka Adhyaya, which show the references of Ganita. एकाच मे त्रिषष्ट मे पञ्चच मे सप्तच मे नवच मे एकादश च मे त्रयोदश च मे पञ्चदश च मे सप्तदश च मे नवदश च मे एकाविंशतिश मे, like this 1 3 5 7 up to 33, and चतस्रश्च मे अष्टौ च मे द्वादश च मे षोडश च मे, like this up to 48 4 8 12 16 up to 48. This shows the progression series. The devotee is asking the god to bestow him the things which are liked by the god and which are liked by the human being in such a way, in the progressive way, so that he can get access to all of them, the nature, the panchabhutas, and get moksha in the final stage. These are the names of few Indian mathematicians: Katyayana, Bahuddayana, Apastamba, Yagnavalka, Panini, Pingala, Aryabhatta, Varahamihira, Brahmagupta, Bhaskaracharya, Mahaviracharya, Pauluri Mallana, Sridhara, Lalla, Narayana Pandita, Jagadguru Shankaracharya, Bharati Krishna Tirtha Swami, Srinivasa Ramanujan, Komaravalu, Chandrasekhar, P.C. Mahalanobis, Neelakanta Somayaji, Shakuntala Devi, Neena Gupta, Suresh Venapalli, Santosh Vempala, Amit Garg, etc. Mahaviracharya, about the importance of Ganita, says, Laukike, Vaidike, Vapi, Tada, Samayike, Piya, Yaha Vyaparastatra Sarvatra Sankhyanamupayujyate. He says that the worldly affairs, the Vedic and the religious activities, drama, architecture, prosody, the movement of the planets, the movement of the sun, everything in the world is related to Ganita. Bauddhayana, he is the son of Shankaradatta and Charumati. He is the Indian mathematician, Vedic sage, and guru of Maharshi Panin. He calculated pi value approximately up to 3 and he used it in the construction of Vedic fire altars. And he says, Dirgha Chaturashrasya Kshanayora Parshvamani Tiryagmani cha Yat Pratak Bhute Kurus Tadabhayat Karodi. The areas produced separately by the length and breadth of the rectangle together equal the areas produced by the diagonal. This is nothing but the Baudhayana theorem, which is equivalent of the present Pythagoras theorem. And he also designed square which is being circled. These are the remains of the ancient Vedic fire altars used for yajnas and homas at Naga temple Mathura and Malhar, and the designs of different Vedas you can see. Shayana Chitti, which is in the form of falcon, Radha Chakra Chitti, which is in the form of wheel, and Kurma Chitti, which is in the form of tortoise. And Katyayana and Apastamba are other two mathematicians or other two Vedic priests and Vedic sages who described about the Shalava Sutras. Katyayana is a Sanskrit grammarian, Vedic priest, and mathematician. He explained about the Shalva Sutras for Vedic fire altars, and he also studied the geometrical shapes based on this Vedic altars. He extended the Baudhayana theorem to all the right angle triangles. Apastamba, he is the student of Baudhayana. He transformed geometrical figures while preserving their areas. Keeping the areas as it is, he transformed the geometrical areas, and he used the Pythagorean triplets in those days for Vedic altars. These are the pictures of Indian mathematicians. Aryabhatta, who can be called as ganithashastra Varenya. He is the Siddhanta period first astronomer. His birthplace is Kusumapura, and according to him, but whereas Bhaskaravan and Nilakanta describe him as Asmakavasi, who studied in Nalanda University. He wrote treatises Aryabhattiya and Arya Siddhanta. Aryabhattiya is found, but Arya Siddhanta is found only in the works of Varahamira, Brahmagupta, and Bhaskara. He says, I am 23 years old, 3600 years into the Kali Yuga, that was 499 CE, and so he was born before 23 years, that is in 476 CE. Aryabhatta, Aryabhattiya book consists of 121 verses, which consists of four parts: Geetika Pada, Ganita Pada, Kalakriya Pada, and Gola Pada. He denoted numbers by using the Sanskrit letters Ka, Kha, etc. And he derived formulae for interest. In algebra he worked on Diophantine equation equivalent in those days. As the modern equations are in the English letters, those equations were in the Sanskrit letters. He derived formulas for summation of first n integers, squares, and cubes. He dealt with identities like a plus b whole square and all, and he gave the closest approximate modern approximate value of pi, which is nearer to the modern value. He gave formula for areas of geometrical shapes. He explained the trigonometrical concepts of jya, kojya, and utkramja, which are sine, cosine, and verse sine. He followed the heliocentric leaning system of planets in astronomy. He explained the movement of celestial bodies is due to Earth's eastward rotation and relative motion. He gave values of year and days exactly which are nearer to the present day values. He was the first to say eclipses are caused by shadows. He gave rotations of Earth per yuga. Brahmagupta, Billamalacharya, he is known as, he is a mathematician and astronomer. He treated zero as number, framed arithmetic operations using zero, and established rules for negative numbers. In Bijaganita, he solved the linear and quadratic equations. He also calculated nx square plus 1 equal to y square, which is known as to be Pell's equation, by using the Bhavana principle of composition method. Calculated diagonals and areas of quadrilaterals by using the formulas. In his work Brahmasputa Siddhanta, he documented works on different parts of mathematics. Bhaskaracharya, he was a polymath, and he was an expert in Vedas, astrology, astronomy, mathematics, metallurgy, life sciences, poetry, grammar, etc. Bhaskara is the author of Karnakutuhala and Siddhanta Shiromani. Siddhanta Shiromani consists of four parts: Leelavati, Bijaganita, Grahaganita, and Goladhyaya. In Goladhyaya, he explains about his birth as a Rasaguna Purnamahi, Samashakana Rupa Samaye, Bhavan Mamotpattihi, Rasaguna Varshena Maya, Siddhanta Shiromani Rachataha, Rasa 6 days, Guna 3 gunas, Purna 0, Mahi 1. The earth is a single one. They are in ascending order of place value, putting them in order 1036 Shakaya, that is 1114 AD. And he was born, and after 36 Rasaguna years, he authored Siddhanta Shiromani. And he says about his family and education: Asit Sahya Kulacharashritapuri Traividya Vidvajjani Nana Sajjana Adhamni Vijjalavide Shandilya Gotrodvija Shrotasmat Vicharasara Chaturo Nishesha Vidyanidhi Sadhunam Avadir Maheshwara Kruti Daivagna Chudamani. He says that his family is on the near the Sahyadri mountains called Vijjalavida. He belongs to Shandilya Gotra, and he is born to a scholar named Maheshwara, who is an expert in Shrauta Smarta Sampradaya, and I am his child and trained under his guidance in different Shastras doing his service. There are many predictions that he belongs to Vidarbha region in Maharashtra, according to Munishwara, but some say that he belongs to Patan in Jalgaon, and some say that Bijapur in Karnataka, and some say that Basra in Telangana. He was the successor of Brahmagupta as the head of astronomical laboratory at Ujjain. His works on arithmetic are properties and operations by using zero. And coming to algebra, that is a Bija Ganita, he determined he determined unknowns and the evaluation of surds and their roots. He used Kuttaka method for indeterminate and Diophantine equivalent equations, and he solved second, third, and fourth degree equations. He used a Chakravala method, which is known as the sophisticated Indian ancient algorithm. He used this to find the number of equations, number of solutions for the equations. In trigonometry, he found out the signs of angles 18 and 36 and formulated the sine of a plus b and sine of a minus b. And before Newton and Leibniz, he worked on calculus. He studied instantaneous rate of change of motion of planets and how they are calculated. Tatkalika, Manda, Shigragati. And in astronomy and geometry, he proposed that the planetary orbits are not perfect circles, which was later proposed by Kepler, predicted eclipse with mathematical accuracy, and he proved the Pythagoras theorem in those days, and it is called as Bhaskara's Pythagoras proof. This is the Leelavati manuscript. He used a problem solving method by the depiction of nature. In Leelavati, a book named after his widowed daughter, Yatam Hamsakulasya Moola Dashakam Medhagame Manasam, Praudiyastalapadmini Vanamaga Ashtam Shako Om Vastatat, Bale Brala Bale Bala Mrunala Shalini, Jale Keli Kriyalasam, Drashtum Hamsa Yugatrayam Cha Sakalam Yutasya Sankyam Vada. In this, he explains that there are the flock of swans in the pond. Out of that, some went to the Manasa lake, some of them went to the hibiscus garden, and the six swans are left, which are couples. Means three couples are in that, and they are enjoying. He takes the unknown as x square, and he takes the which went to the hibiscus garden as 1 by 8th of x square, and he takes the remaining as root of x square into 10 that went to the Manasa lake, that is 10x, and he solves the equation in this way by using his method where he adds a b square by 4 on both sides to solve the equation. And there is another problem in the same Leelavati where he uses the Mahabharata Kurukshetra war to explain, to solve a problem. See, there Partha Karnavadaya Marganaganam Kruddhorane Sandade. He explains a situation in Mahabharata and he devises a problem. So, in this, Arjuna, in order to, in a rage, going to kill Karna takes a bunch of arrows, and out of that, half he uses to kill the horses, and the remaining he uses to destroy the spear, chariot, flag, and finally, with one arrow, he kills Karna. So the legacy of Bhaskaracharya is very high. He is a visionary, great mindset. He explained the problems through depiction of nature, epics like Mahabharata, Ramayana, etc. And he is the inspiration for Indian mathematicians, Islamic scholars, and even the medieval European scientists. He did it all in the quiet observation. And this was passed through scripts, through stories. Srinivasa Ramanujan. He is born on 22 December 1887 in Erode, Tamil Nadu. His basic education about Dharma and geography was from his mother. After reaching higher secondary education, he was only interested in maths and not in any other subject, which has won him many prizes. He received a book called A Synopsis of Elementary Results in Pure and Applied Mathematics, which changed his life. He met Deputy Collector V. Ramaswamy Iyer and R. Ramachandra Rao, who introduced him to the Journal of Indian Mathematical Society, in which his works were published. And Narayan Iyer, Rao, and E.W. Middlemaster sent his works to British mathematicians, which was not accepted. But finally, G.H. Hardy was the one who accepted it and called him to Cambridge. Ramanujan was not ready to go to Cambridge. He felt fear of religious conversion. And finally, getting assured that no religious conversion would take place, he reached Cambridge and worked on a number of the mathematical problems. He worked on infinite series, and he worked on Ramanujan-Hardy asymptotic formula, which this asymptotic formula is used to understand the behavior of system and describe resource consumption for algorithms when input reaches the maximum limit, and how to manage that situation. And it is used in fluid dynamics in the turbines in the machines where the flow over the surface takes place, and it is calculated by Navier-Stokes equation. In structural engineering, in building the different structures, how the pressure acts and at what stage the limit ex exceeds, and how to manage that situation. In electrical engineering, current voltage characteristics in MOSFET devices. Ramanujan's work, he used circle method to find a Dedekind n function. He gave a Ramanujan Hardy number. When Hardy came to visit Ramanujan in hospital, he came in a taxi cab 1729 and called it as unlucky. Ramanujan expressed that it is the cubes of two numbers in two different ways, and Hardy was astonished. He dreamt of Ramanujan used to dream of Namagiri Tayar and Narsimha Swami with drops of blood followed by complex mass. He says that an equation is nothing if it does not give the feel of God. He was a fellow of Royal Society of Trinity College, Cambridge. He was fellow of the London Mathematical Society. He received a K. Ranganath Rao Prize and posthumous recognition of his birthday as the National Mathematics Day, and a Shasta Ramanujan Prize in his memory. He died on April 26, 1920 due to hepatic amoebiasis. Shakuntala Devi, born 4th November 1929 in a middle class Brahmin family. Her father was very poor and worked in circus. She was a self learner. She did not have any prior education. She visited many Indian and foreign educational institutions after getting a strong hold on the cube roots. She calculated 23rd cube root of 201 digit number in 50 seconds, and in comparison to Univac computer, which calculated in 62 seconds. And in Imperial College London, she multiplied two 13 digit numbers and gave the 26 digit answer in just 28 seconds, which earned her a Guinness Book Records. And she was awarded Ramanujan Mathematical Genius Award in 1988 and Google Doodle on her birthday in November 4th, 2013. Her literary works on mathability, awaken the math genius in your child, more puzzles to puzzle, book of numbers, etc. And Nina Gupta, the contemporary mathematician. Nina Gupta. She was born on 24th November 1984. She completed her PG from Indian Statistical Institute at Kolkata. Her works are on commutative algebra, affine algebraic geometry, Laurent polynomial fibrations, and received Shanti Swarup Bhatnagar Prize, etc. Amit Garg, who was born in 1978 Haryana, Indian founder of Orme Company, and he's recorded in Guinness and Limca book records for mental calculations, and he participated in the mental calculation World Cup and completed 10 tasks of dividing 10-digit number by the 5-digit number in 5.45 minutes without any remainder left. He won Sports Olympiad for mental calculation. Santosh Vempala, born 1971, Visakhapatnam, Andhra Pradesh. Computer Science, IIT Delhi, and Georgia Institute of Technology. He is working on Gaussian cooling and algorithms, randomized algorithms, comparison geometry. He won the Fulkerson Prize, Guggenheim Fellowship, and American Mathematical Society Fellowship. Manjul Bhargava. He born 18 August 1974, Indian origin, and lives in Canada. Princeton University. He works on Gaussian classical law, solutions of quartic and quintic numbers, generalization of factorial function, and he designed a Bhargava cube, average rank of elliptical curves over cube with Arul Shankar. His awards are Padma Bhushan and Infosys Award 2012. Suresh Venepalli. He was born 1966, Vangur, Nagar Karnool, Telangana. Schooling at JBHS Vangur. He got PhD from Tata Institute of Fundamental Research. He is working on zero cycles on quadratic vibrations, finiteness theorems, isotopy of quadratic forms, Hermitian analysis of theory of Springer, and he is awarded with American Mathematical Sciences Award in 2009 and Andhra Pradesh Young Scientist Award in 2008. AI based artificial intelligence based on the basics of Bharatiya ganithashastra. Panini's Ashtadhyayi Sutras have recursive method for Sanskrit language, which is used as a basic for developing string functions and a recursion method in many computer programming languages and base for many algorithms. It was known as the Bacchus Nor form. In 1967, Peter Jirahi Ingerman named it as Panini Bacchus. Based on Srinivas Ramanujan's work, an AI machine named as Ramanujan machine is made which produces number of problems, solutions and equations. The cyclic method introduced by Bhaskaracharya, which is called as the Chakravala method, which was known as Brahmagupta as the Bhavana or composition method, is nothing but the iterative process used in computer sciences and other places. It is just like the sophisticated Indian ancient algorithm. Thanks. Thanks to IKS for providing me this chance to give the presentation on Ganithashastra.